Hello folks, in this video we'll be solving the trapping rainwater problem, which is a hard level LeetCode problem. So here the question is, we'll be given a positive integer array which can be represented as this bar graph, right? So we need to find how much water it can trap inside it, right? From this picture, the question is clear. So how we can approach this problem is, for each element, like it's an integer array, right? So for each element, that is at each index, we can calculate, like for this particular bar graph, for this particular bar, how much water it can hold, that is how much water it can trap above it, right? So we'll be looping through the array, and for each element we'll see how much water can stay above that particular bar, above the bar we are considering currently. Okay, so before we start, there are three observations here for this problem. The first observation is, here for the first and last bar, it cannot trap any water, right? Because it's at the both the ends, right? So for if we consider the first one, for the first bar, we can it doesn't have a bar before that, so it cannot trap any water, right? Same way for the last bar also, it doesn't have any bar after that, so even the last bar cannot trap any water, right? So for the first and last bar, we need not have to consider anything. The amount of water it can trap will be 0. Okay, so we need to find for all the other elements, that is from index 1 till n-2, right? That is apart from first and last, we'll be calculating for rest all the elements. Okay, so that is first observation. Now second observation is, let's take a small example. So for this example, if we look at it, we can see that for this particular element under consideration, we can say that the amount of water we can trap inside this is dependent on the bars on left and right side of it, right? That is the bars which are greater on the left side and greater on the right side, right? That is the highest bars which are on the either side of this element will be the limiting factor for trapping the water, right? And again, if we are trapping the water for this particular element, the lowest, that is the minimum bar, the bar with minimum height, when we compare the left and right side bars, right? That is the minimum among these two bars will be the limiting one, right? So what we can do is, when we iterate through the elements, for each element we can check, like which is the bar which is limiting its capacity, its capability to trap the water, right? So the we'll take from both sides, from left side and right side, we'll take the highest bars, and among them the bar with least height will be the limiting one, right? So we can do that. That is the second observation. Now again, third observation can be like, let's take the same example. So here, let's say the element under consideration is a bit larger than the bars on the left and right side of it. Okay, so in that case, it cannot trap any water, right? That is, this element is higher than the bars which are at left and right side of it, so it cannot obviously cannot hold anything, right? So water will be flowing out of it. So for if at all the element under consideration is bigger than the bars on the either side of it, then we can simply ignore it, because it cannot hold any water, right? That is the third observation. So with these observations, let's start coding. Okay, so what we can do is, let's say we can create an array first, that is for each element we need to store some information, right? So we can create an array of length, the length of this array input. So length n equal to len of height. Now we can create a limiting array, that is an array to store the limiting bars. For each element we'll calculate which is the limiting bar for it. Like we'll calculate which is the maximum bar on left and which is the maximum bar on right side, and later on we'll be taking the minimum of it. Okay, so we can say limiting bars equals we can store an array inside array. Okay, for this, like for each element we can store the information in an array, and inside this array we can store the left maximum and right maximum. Okay, so let it be 0, 0 for now, and we need n elements, right, for in range n. So we created a limiting bars array which contains arrays, that is which contains n arrays. Okay, currently initialized with 0, 0. And as I told before, for the first and last, we not have to consider anything, because they cannot trap the water, right? So it will be 0. So what we need to do is now we can start calculating which is the maximum bar. For each element we'll calculate what is the maximum bar on its left side. Okay, first we'll do that. So we'll use a for loop for that. For I in range, we'll be looping from first element till the second last, right? Yeah, so n minus 1, that will be for I in range 1 to n minus 1, right? Yeah, correct. So here what we can do is limiting bars of I of, so we are calculating the left maximum. Okay, so left maximum will be stored here in the at index 0. So we are calculating this. So 0 equals, we want the maximum, right? The maximum bar on the left side. So it can be either when we are considering an element, the maximum bar left to it can be the immediate neighbor, right, which is on left to it, or it can be a maximum bar which was there before, which we do not know. But the element before, the neighbor of the element under consideration knows which was the maximum bar which was there on the left side, right? So what we can do is we can write this maximum of either it will be height of I minus 1, that is its immediate neighbor, or we might have already calculated the previous values, right, as we loop through the array. So what we can do is we can use the previous, we can see whether there was a bigger element on the left side. Okay, that is limiting bars of I minus 1 of 0, right? So through this statement we'll update the maximum bar for each of these elements. Okay, now once we are done with that, we need to calculate the right maximum, right? For that, again we'll write the for loop for I in range, and this time we'll be starting from the rightmost end to the leftmost. Okay, in reverse. So what we can do is from n minus 2 till 1, right, till index 1. So 0, 0. So we'll be moving backward. So we need to type minus 1. Okay, so for I in range, okay, this is correct. Now limiting bars of I, and here we are calculating the right value. So here the index will be 1 equals max of, the similar way we can write it, right? That is I plus 1. Either it will be the neighbor on the right side, or it can be already calculated value, right? I plus 1 of 1. Now we have calculated the maximum bar on the left and right for for all the elements. Okay. Now we can calculate, like as I mentioned in the beginning, what we can do is we can simply see for each element how much water it can hold or trap on top of it. So that will be determined by the level, water level, right? So since anyway we have this uh, the bars, that is limiting bars information. So with that we can easily calculate, right? So we can again write a for loop range 1 to n minus 1. We need a variable, right, to store the result. So let's say we can name it total water equals 0. Let it be 0 initially. So from here, what we need to do is we need to get the minimum, right? Like we have already calculated the limiting bars, that is which are the highest bars on left and right. Now what we need to do is we need to select the minimum among them, minimum among these two highest bars on the either sides, right? So anyway, because minimum will be the one which will determine how much water it can hold, right? A water cannot go above the level of the minimum bar, so we'll select the minimum. So water level equals minimum of we have this calculated result, right? So lim bars of I. For this particular element, we'll take the minimum of the bars on the left and right, the highest bars on the left and right. Now we have the water level, and also I have mentioned that if the water level is water, like our element under consideration, if it is greater than or equal to the water level, then obviously it cannot hold any water, right? So we can put that conditional check here, that is if height of I greater than or equal to, or we can check like this, if height of I is less than water level, only then we can calculate the water, right? We can add that particular water, right? So total water plus equals the height of I. So that is it, I think. So for each element we will be calculating how much water each element can hold above it. Okay, so at last after the loop we'll have the result stored in total water variable. So we'll return it. So return total water. So let's try running it. There's some error. Let's see. Yeah, sorry. So when we are calculating the amount of water a bar can hold, what we need to calculate is, that is the water level minus the height of the bar, right? So here I have written it wrongly. It's actually the water level minus the height, right? That is water level at that particular index minus the height of the bar at that particular index. That will give the water it can hold at that particular index, right? So that we will add to total water. Now let's try running it. Let's submit it. Yeah, it's working fine. See you in the next video. Bye.